Reference electrode is an electrode whose electrode potential is known to us, as well as it is used to measure the electrode potential of other electrode. If you convert log natural to log to the base 10, it is 2.303 RT by NF log to the base 10 Kc. The potential of the given electrode, if it is equal to plus EMF, she is anode. If it is minus EMF, she is cathode. Hello my dear students, I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome to 6th session of chapter Electrochemistry. In the previous session, I discussed about electrochemical cell and type, electrode potential, standard electrode potential, Daniell cell and symbolic representation of galvanic cell. In the today's session, that is in the 6th session, I am going to discuss about measurement of electrode potential, standard electrode potential, list of standard electrode potential, Nernst equation, relationship between equilibrium constant and EMF of a cell, relationship between free energy change and EMF of a cell, relationship between standard free energy change and equilibrium constant, and difference between EMF and potential difference. The today 6th session content as shown in the board. Okay, so these are the contents today I am going to discuss in the 6th session. Okay, now let us consider first topic, the measurement of electrode potential. Measurement of electrode potential. Already you know about definition for electrode potential. Electrode potential is the potential difference between electrodes when an element is dipped in its own ions, that is in contact with its own ions, when it is dipped in its own salt solution. It is denoted by E. If you want to calculate or measure electrode potential of an electrode, you have to connect that electrode to another electrode whose electrode potential is known to us. The electrode whose electrode potential is known to us, it is called as reference electrode. Reference electrode. Therefore, for example, these are the two electrodes. This is an electrode. We have to calculate its electrode potential. We don't know the electrode potential of this electrode. This electrode is connected to reference electrode. If I consider this as a reference electrode, its electrode potential is known to us. These two are connected to each other, and EMF of the cell is calculated or measured by using potentiometer. From the EMF value as well as the electrode potential of reference electrode, one you can calculate the electrode potential of an electrode whose value is not known to us. So therefore, what is reference electrode? Reference electrode is an electrode whose electrode potential is known to us, as well as it is used to measure the electrode potential of other electrode. Now, commonly the reference electrode used here is standard hydrogen electrode. Why standard hydrogen electrode is used as a reference electrode? Because its electrode potential value is 0 voltage. Its electrode potential value is 0 voltage at all temperature. That's why hydrogen is considered as reference electrode, as well as it is called as standard hydrogen electrode. Standard hydrogen electrode, SHE. Therefore, to calculate or measure electrode potential of any other electrode which is considered as a reference electrode, the reference electrode is standard hydrogen electrode whose electrode potential value is considered to be 0 at all temperature. So, electrode potential of an electrode can be measured by coupling the given electrode with another electrode of known electrode potential. It is called as reference electrode, and by measuring the EMF of the cell formed. Absolute electrode potential of the given electrode could have been measured if the reference electrode has 0 potential. Since no reference electrode can be set with its potential equal to 0, the absolute electrode potential cannot be determined. Therefore, the potential of an electrode measured relative to standard hydrogen electrode whose potential is to assume to be 0 at all temperature. Standard hydrogen electrode whose electrode potential is assumed to be 0 at all temperature. So, therefore, standard hydrogen electrode is used as a reference electrode to measure electrode potential of any other electrode. Therefore, now you have to know that how to construct standard hydrogen electrode. Now, standard hydrogen electrode is a primary standard reference electrode. Primary standard reference electrode. How it is constructed? Let us consider a platinum foil. It is a platinum foil. Platinum foil you have to take, and it is coated with platinum black. It is coated with platinum black or platinized asbestos. Platinum black. This platinum foil is coated with platinum black or platinized asbestos to increase the surface area. So, as well as when surface area increases, the absorption of hydrogen gas is also increases. What is adsorption? One substance get accumulate on the surface of the other is called as adsorption. Here, which one is get adsorbed? Hydrogen gas molecules are get adsorbed on platinum foil which is coated with platinum black. So, to increase the adsorption of hydrogen on the platinum surface, so it can be coated by platinum black. Okay. Now it is sealed to platinum wire. This is a platinum wire. Okay. It is covered by glass jacket. Little of mercury is placed inside the glass jacket to make or break the contact of standard hydrogen electrode with other electrode. So, the mercury is placed here to make or break the contact of standard hydrogen electrode with other electrode. Now, the platinum foil is partially immersed in 1 molar HCl solution. Why you have to take 1 molar? Because it is a standard hydrogen electrode. When it is standard condition, the concentration of the solution should be 1 molar and the pressure of the gas must be 1 bar. The platinum foil is dipped in 1 molar hydrochloric acid. So, and we have to pass pure hydrogen under 1 bar pressure. The platinum foil is partially immersed in 1 molar hydrochloric acid and hydrogen gas is bubbled just below the surface of hydrochloric acid to maintain the partial pressure of hydrogen at 1 bar. What's the concentration of the HCl used? The concentration of HCl used is 1 molar. Okay. Now, the hydrogen gas bubble is get adsorbed on platinum plate hydrogen ions and it comes in equilibrium with hydrogen ion. So, H plus ions is in equilibrium with hydrogen gas. The potential of She is assigned to be 0 at all temperature. So, the electrode potential of given electrode is measured by coupling it with She and by measuring the EMF of the cell formed. Therefore, She is connected with other electrode whose electrode potential is to be measured. The potential of the given electrode, if it is equal to plus EMF, She is anode. If it is minus EMF, She is cathode. Okay. So, if the potential of the given electrode is plus EMF, She is anode. If it is minus EMF, She is cathode. According to convention, symbolic notation of standard hydrogen electrode is hydrogen get adsorbed on platinum plate. So, the hydrogen gas at 1 bar pressure, it is in contact with H plus ions. So, the concentration of the solution should be 1 molar. So, this is about standard hydrogen electrode and it is symbolically represented as hydrogen gas get adsorbed on platinum plate which is in contact with H plus ions. H plus ions are produced from 1 molar HCl solution. Next, how can you calculate the E naught of zinc by using standard hydrogen electrode. The standard hydrogen electrode is act as reference electrode. The given zinc electrode is coupled with She, that is standard hydrogen electrode. The EMF of the cell is measured by using potentiometer and is to be find out 0.78 volt. In this cell, zinc electrode is negative, that is anode, relative to the hydrogen electrode. You know that E0 cell is equal to E0 cathode minus E0 anode. So, E0 cell is equal to cathode is reference electrode, that is standard hydrogen electrode. It is E0 zinc. So, if you want E0 zinc, so E0 of She minus E0 of, that is EMF of the cell. So, E0 of standard hydrogen electrode is 0 voltage minus 0.76 volt. It is equal to minus 0.76 volt. Anode of reaction, zinc in solid form going to lose 2 moles of electron and it will form Zn2 plus. Cathode half reaction, 2 H plus ions in aqueous solution takes this 2 moles of electron and it hydrogen gas is liberated. So, overall cell reaction is 2 H plus zinc give rise to H2 plus Zn2 plus. Cell notation, zinc in contact with in solution whose concentration is 1 molar, H plus ions in concentration 1 molar, hydrogen is in contact with H plus ion. So, it can be separated by double vertical line represents it is a salt bridge. Now, list of standard electrode potential. Observe here. I am going to show some of the table. So, here, one first table and this is the second table, third table, fourth table. I observe had given the list of standard electrode potential values of some metals and metal ion standard E0 value has given. Okay. So, observe here. So, the E0 values are in the decreasing order, Fluorine with highest E0 value plus 2.87. Next, lead dioxide 1.69, next 1.51, 1.50. So, as you observe, its E0 value is decreasing. Therefore, it is also called as electrochemical series. Hagar, what is electrochemical series? Electrochemical series is a list of some electrodes which are arranged in the decreasing order of their standard electrode potential or standard reduction potential. Standard electrode potential or standard reduction potential. Was the significance of this electrochemical series or was the significance from if you know the standard electrode potential? From the standard electrode potential or from the standard reduction potential, one you can know that element is whether it's an oxidizing agent or it's a reducing agent. Oxidizing agent or it is a reducing agent. Okay. So, higher the value of E0, that element or electrode act as it has a greater oxidizing ability and lesser reducing ability. Therefore, any electrode whose E0 value is high, which has a greater oxidizing ability and lesser reducing ability. The values of standard electrode potentials E0 can be used to predict the ability of the species as an oxidizing agent or reducing agent. Higher the standard electrode potential, greater is the oxidizing ability and lesser is the reducing ability. In the second table, so the standard electrode potential of species decreases from top to bottom. Therefore, the oxidizing power of the species decreases from top to bottom. As you observe in the table, so the E0 value decreases from top to bottom. That indicates that its oxidizing power of the species decreasing from top to bottom. In this table, which has high E0 value, fluorine has high E0 value with plus 2.87. Therefore, it's a fluorine gas is the strongest oxidizing agent. Fluoride ions are the weakest reducing agent. So, the example, the standard electrode potential of fluorine has the highest value, indicating that fluorine gas has maximum tendency to get reduced to fluoride ions, and therefore fluorine gas gas is the strongest oxidizing agent. Fluoride ion is the weakest reducing agent. Lithium has the lowest E0 value electrode potential. This indicates that lithium metal is the most powerful reducing agent. Therefore, from this table, one you can say fluorine is a powerful oxidizing agent because its E0 value is high. Lithium is a powerful reducing agent because it has lowest value of E0. Therefore, from standard electrode potential or from standard reduction potential, one we can predict whether the element or an electrode is a very good oxidizing agent or reducing agent. Higher the value of E0, it's a powerful oxidizing agent. Lower the value of E0 value, they are powerful reducing agent. One more thing, if the standard electrode potential of electrode is plus, that is greater than 0, the ions are reduced by hydrogen. That is, in electrochemical series, the metals which are present above hydrogen with positive E0 value, these ions are reduced by hydrogen. If the standard electrode potential of an element is negative, then hydrogen ion is reduced by the metal. Here, hydrogen has 0 voltage. Its E0 value is 0 voltage. The metals which are present above hydrogen as well as metal present below hydrogen. Which are present above hydrogen, they have positive E0 value. Below hydrogen, they have negative E0 value. Those have positive E0 value, their ions are reduced by hydrogen. If it has negative E0 value, hydrogen only reduced by that metal. My dear student, I explained about electrode potential. What's the significance of electrode potential? From the electrode potential value, one we can predict and metal behaves as oxidizing agent or reducing agent. Therefore, how can you calculate electrode potential of a metal electrode? It can be calculated by using one equation. That equation is called as Nernst equation. General electrode reaction, metal ion in aqueous medium takes n moles of electron and it becomes metal in solid form. The electrode potential at any concentration can be calculated by using which equation? Nernst equation. What's the significance of Nernst equation? Nernst equation is used to calculate electrode potential of electrode. So, electrode potential of electrode is calculated by using formula electrode potential of metal electrode is equal to standard electrode potential of metal electrode minus RT by NF log natural molar concentration of metal divided by molar concentration of metal ion. It's an Nernst equation, but concentration of solid metal is taken as unity. Therefore, we have electrode potential of metal electrode is equal to standard electrode potential of metal electrode minus RT by NF log natural. It must be considered as 1. Therefore, it will become 1 by molar concentration of metal ion. The numerator become 1. Therefore, this expression becomes 1 by molar concentration of the metal ion. In this equation, where E0 of metal electrode is equal to standard potential of the electrode, R is molar gas constant or universal gas constant whose value is 8.314 joule per Kelvin per mole. T is temperature in Kelvin. F is Faraday constant is equal to 96,487 coulomb per mole, which can be approximately equal to 96,500 coulomb per mole. N is equal to number of electrons involved in electrode reaction. Molar concentration of m to the power of n plus means concentration of metal ion. This is concentration of pure solid metal. So, we have substitute all these in this equation. One, you will get the electrode potential of metal electrode. Therefore, what's the significance of Nernst equation? Nernst equation is used to calculate electrode potential of metal electrode. Next, relationship between equilibrium constant Kc as well as E0 of the cell. Galvanic cell involving the net cell reaction of the type A moles of A plus B moles of B give rise to C moles of C plus D moles of D. Nernst equation can be written as E cell, electrode potential, E cell is equal to E naught cell minus RT by NF log natural. So, molar concentration of the product should be in the numerator, molar concentration of the reactants in the denominator, and its power is nothing but its stoichiometric coefficient. Here which are product? C and D. Therefore, the product of the molar concentration of the product raised to the power stoichiometric coefficient, denominatorly product of the molar concentration of the reactant raised to the power of stoichiometric coefficient. So, it is nothing but Kc, equilibrium constant. Therefore, E naught cell is equal to RT, if you take E naught cell is equal to RT by NF log natural Kc. E cell is equal to E naught cell minus RT by NF log natural Q. Q is reaction quotient. Reaction quotient is equal to product of the molar concentration of the products raised to the power of stoichiometric coefficient, product of the molar concentration of the reactant raised to the power its stoichiometric coefficients. Okay, at equilibrium, when E cell is equal to 0, the reaction quotient Q become what? Kc, where Kc is the equilibrium constant. Therefore, E naught cell is equal to RT by NF log natural. Instead of Q, you can substitute Kc. If you convert log natural to log to the base 10, it is 2.303 RT by NF log to the base 10 Kc. This equation gives a relationship between equilibrium constant and the standard cell potential, where temperature 298 Kelvin and 1 Farad is equal to 96,500 Coulomb, R is equal to 8.314. If you substitute these values here, the simplified form is E naught cell is equal to plus 0.0591 divided by NF log Kc to the base 10. This is the relationship between E naught cell and Kc is what? Equilibrium constant. Kc is what? Equilibrium constant. Okay. So, this about the relationship between equilibrium constant as well as E naught cell. So, in Daniell cell, at any given concentration, Cu2 plus ion as well as Zn2 plus ions at 298 Kelvin for the net cell reaction is zinc solid plus Cu2 plus ions in solution give rise to zinc ions in solution and copper in solid state. The Nernst equation is given by E cell is equal to E naught cell minus 2.303 RT divided by, in place of N, I'll write 2 because 2 electrons are lost during the reaction, 2F log to the base 10. So, molar concentration of zinc ion divided by molar concentration of copper ion. E cell is equal to E naught cell minus 2.303, R value is 8.314, temperature is 298 Kelvin. So, 2 Farad is equal to 96,500 log to the base 10 molar concentration of zinc ion divided by molar concentration of copper ion. Therefore, E cell is equal to E naught cell minus, if you simplify this, we'll get 0.0591 divided by 2 log molar concentration of zinc ion and molar concentration of what? Copper ion. In Daniell cell, when the circuit is closed, the concentration of zinc ions keep on increasing while the concentration of Cu2 plus ions keep on decreasing. At the same time, the voltage of the cell as read on the voltmeter keeps on decreasing. After some time, we shall note that there is no change in the concentration of Cu2 plus ions as well as Zn2 plus ion. Voltmeter gives 0 reading. In the voltmeter, you are observing 0 reading. This indicates that equilibrium has been established. Equilibrium has been established or equilibrium has been attained, at which E cell is equal to 0. Therefore, the molar concentration of zinc ion divided by molar concentration of copper ion become Kc. Therefore, E naught cell is equal to 0.0591 divided by 2 log Kc. Next, relationship between standard free energy chain, that is delta G naught, and E naught cell. So the electrical work done in joules is the product of potential difference and charge in the cell. Okay. Therefore, maximum work done is equal to E cell into charge. It is the product of the potential difference, electrode potential into what? Charge. The maximum work done on the surrounding is equal to the decrease in the standard free energy change. Therefore, maximum work done is equal to minus delta G naught. So when you substitute minus delta G naught here, minus delta G naught is equal to E cell into charge. Charge is NF. Therefore, delta G naught is equal to minus NF E naught cell. Delta G naught is equal to minus NF E naught cell. E naught cell. What is N? N is the number of the electron lost or gained during the reaction. F is equal to 1 Faraday, 96,500 coulombs. E naught cell is standard electrode potential, or it is EMF of the cell. Okay. Next, the relationship between standard free energy and equilibrium constant. The relationship between standard free energy and equilibrium constant is given by delta G naught is equal to minus 2.303 RT log Kc. What's the relationship between delta G naught and equilibrium constant? Standard free energy change and equilibrium constant. The standard free energy change and equilibrium constant are related by delta G naught is equal to minus 2.303 RT log Kc. From delta G naught value as well as from K value and E naught cell, you can decide whether the reactions are spontaneous, non-spontaneous, or reaction has been established equilibrium. So when the reactions are spontaneous, delta G is less than 0, that is negative. K and E naught are positive, greater than 1 as well as greater than 0. When delta G naught is 0 and K is 1, E naught cell is 0, it is at equilibrium. Delta G naught is greater than 0, that is it is positive, and it is less than 1 as well as it's less than 0. So it is non-spontaneous. It is non-spontaneous. Okay. Next, what is the difference between EMF and voltage? EMF is the potential difference between two electrodes when no current is flowing in the circuit. It is the difference of the electrode potential of the two electrodes when the cell is under operation. EMF, there is no current in the circuit. Here, the cell is under operation. It is the maximum voltage that cell can deliver. It is always less than the maximum value of voltage which is the cell can deliver. It is responsible for the steady flow of current in the cell. It is not responsible for the steady flow of current in the cell. It is measured using potentiometer. It is measured using voltmeter. EMF can be measured by using potentiometer. Here, the cell potential or voltage is measured by using voltmeter. This is the difference between EMF and potential difference, that is voltage. Okay. So, already I explained Nernst equation and what's the relationship between delta G naught and Kc and what's the relationship between delta G naught and E naught cell. So that problems in the next session, that is in the 7th session, I'll come up with the numericals as well as the new, that is concept, that is batteries. Okay. So therefore, my dear student, next session I'll come up with new concept, that is what batteries, as well as I'm going to solve so many numericals which is related with Nernst equation. Until then, goodbye. Thank you.